us, okay? All right, so some things to remember. That's the other thing I haven't opened up yet. Hang on. There we go. Okay. Got everything open that I need now. And we're going to go present now. So I'm hitting present now. So you should get to see my screen now. All right, so you should be seeing my screen about now. Should have all your little faces on it. All right. The first thing is we are in the middle of a Titan Spirit Week. Okay. Today was Theater Thursday. I did post a picture of myself at 6 o'clock this morning watching my favorite BC Live videos. So, because that's about as good as I can get for movies right now. They don't have Hallmark movies on that early in the morning.
They have Golden Girls?
Yeah. It's supposed to be theater. All right, and then tomorrow is dress up in comfy clothes and blankets.
Easy.
All right, so we will be seeing comfy clothes and blankets tomorrow, okay? For calculus tomorrow, let's see. Bye. All right. Today was Shrek. Tomorrow is High School Musical. Tomorrow our meet times change a little bit because I've got something going during when we normally meet. So for tomorrow, BC is going to be from 1 to 2. And ABBC together is going to be from 2:30 to 3:30. And if BC, if we run a little over, then you get an extra little bit of time, or we can take a break. It's kind of up to you guys. Saturday, BC will be from 1 to 2, and the combined ABBC will be from 2 to 3. And we're going to be doing Incredibles 2, specifically, is what Andy said on Saturday. Okay. And then the questions that we're going to do are listed there. Tomorrow we're going to do position, velocity, acceleration. AB gets the derivative version of it this year. BC, you could go derivative or integral of it. Typically in BC it's a parametric thing, but this year it wouldn't be if it shows up. Okay. All right. I wanted to show you really quickly. There is a whole bunch of stuff on College Board. Okay. If you just start even where it just says coronavirus updates, okay, and they start talking about the exams and you can explore the site. If you probably hit information, let me see where this takes us because I haven't gone through this way yet. Go to where it's at. If you want, you need to explore this a little bit, okay? Go to hit taking exams and learn more. There's all kinds of stuff. It talks about notes. It talks about the time. It talks about getting ready for the exam day. It talks about the exam days. And look at this. It says interactive demo that simulates the online exam experience. It also gives you some submission guidelines. Hopefully, I don't know if any of you are taking AP Spanish, but if you're taking AP Spanish, you probably got a survey that you need to answer if you don't have your own cell phone or iPad, because the world languages have to be on iOS or Android phones. Okay. That's the only way they're taking the exam this year. So make sure that you've answered that survey from the district. All right. So there's a lot of interesting things in here. They talk about exam security. You might want to make sure you understand that. The thing that I kind of wanted to point out, and this is where you need to go play with it, is this interactive demo. For right now, everybody's just going to use the word practice to type in here. So you type in the word practice and it forces caps, and then you hit continue, and then it starts going through just entering your personal information and then the question and the response, and it gives you a timer so you can kind of mess with the timer part. It doesn't give you any questions. It's just to help you learn how to prepare to upload your exam. And you can practice with it all the different ways, okay? My suggestion is still bring it up on your Chromebook or laptop, the test. Do it on paper. Take a picture with your phone, or if you can figure out how to do it with your Chromebook if you don't have a phone. I would turn it into a PDF because that's off directly. I snap it directly from the PDF app and try to get it to my Google Drive on my phone and upload it from Google Drive on my Chromebook or my laptop. Okay. Make sure you practice though. You have to practice. And as you're submitting things for me, do that same process so you're getting really, really good at it. Okay. All right. So that's my spiel on new stuff. Any questions about that? I see a couple of comments. All right. Okay. I'm going to close that out. And actually practice with the entire timer, even though it seems like a waste of like 20 minutes, because then you can see how it flashes and everything. Okay. I did play with it a little bit in a Chromebook. I did it mostly on my laptop, but it does work with the Chromebook. Okay. All right. Let me go back to here and we're going to get started. Today we are doing 2017 number 5 and number 6. Pull this stuff off. Okay, I'm going to go ahead and flip this and get going. So I'm going to read number 4. Remember, hopefully you have it in front of you. And I totally have that typed wrong. It's not number 5. It's supposed to be number 4. So I apologize. That was my fault. It's a typo. At time t equals 0, okay, a boiled potato is taken from a pot on a stove, left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius. I wrote that down. At time t equals 0. That's basically what we would call our initial condition. Okay. And the internal temperature of the potato is greater than 27 degrees Celsius for all times t greater than 0. So basically it's always 27 degrees Celsius. It never gets lower than that. That probably means that might be room temperature. The internal temperature of the potato at time t can be modeled by the function h. So h is the function of the internal temperature, but then they say that satisfies this differential right here, okay? Where h of t is measured in degrees Celsius and h of 0 equals 91. So they've actually given us this information twice. They told us it here and they gave it to us here. So we're definitely probably going to have to use that initial condition somewhere in the problem. The first thing we're supposed to do is write an equation of line tangent to the graph of h at t equals 0. And then we're going to use this equation to approximate the internal temperature of the potato at time t equals 3. So that means that we need 2 things for equation of a tangent line, because they actually want the equation of a tangent line, not the slope. They said equation of tangent line. So we need a point, we need a slope, and we're supposed to be doing this at t equals 3, okay? Or estimating at t equals 3. So we actually do have a point. They gave us this point right here. So our point is h of 0 equals 91, or 0, 91 would be our point. Okay. To get the slope, we know that comes from the derivative. So I know I've got a derivative here, which means I'm going to plug these values into the derivative. So dh dt of x equaling 0 equals, and the 0 I got from right there, negative 1/4 times 91 minus 27. Okay. Now, I could leave that like that and plug that in this as in is the slope. If I didn't have to do the calculation where I did approximate 3, maybe I would do that. If I'm nervous about getting my numbers wrong, I can make it look a little uglier. That's okay. So I've got negative, go away. I don't know why it's not going away. All right, so negative 1/4 times 64, and that ends up equaling negative 16 for my slope. So I'm going to put it into point slope equation of a line. You got y minus the y value, which is 91, equals the slope of negative 16 times x minus the x value. Because I'm going to have to use this to estimate, I would probably, because this is the line tangent to the h, you don't have to put it in terms of h because it's the line tangent to h, so y equals is fine. But I am going to move the 91 to the other side, and I'm going to get rid of the 0. So it's really negative 16x plus 91. I'm only doing that because I still have to plug into it. We do need to approximate the temperature at t equals 3. Oh, I should have used x's, huh? I should have used t's in place of where I put the x's, so I'm going to switch that to a t. Because it said dh dt, huh? So let's use t's instead of x. All right, so I'm going to go ahead and plug that in. I'm going to plug in a 3. So y equals negative 16 times 3 plus 91. I would not do anything more than that. You should stop right there. For those of us that actually need it. Oh, I didn't even write down the answer. That's nice. It's 43. Okay. So you do need to label it, and it doesn't hurt to end it with a sentence. So therefore, the internal temperature of the potato. Is there an E on the end of that? I don't know. Potato, no. At time t equals 3 is negative 16 times 3 plus 91 degrees Celsius. I know that looks weird, but it's okay. Leave it like that. There's an acronym that I've learned from watching the live sessions, and I thought this was kind of interesting. So when you're trying to write an answer, there's typically some things that they look for when you have to write a concluding sentence. So if you use the acronym NUT, okay, it stands for noun, unit, and time. So when you're writing a sentence, make sure you have all those things in there. Noun is like the words of the problem, okay? And we've called those the words of the equation a little bit. So our noun would be the internal temperature of the potato, okay? The unit would be our degrees Celsius, and then we always have to identify time, even though it's not there. Marilena, I'm not sure on that one completely. I'm noticing a T in the answer key. That's why I put it there. And it does need to be a T because it's related to time, okay? Would H variable in place of Y matter? Yes, Delaney, it would matter because they told us that H was the original function, and we're supposed to be writing an equation of line tangent to that function, okay? So watch your variables. You do need to be detailed and be careful, okay? And I have never been a grader, and that I haven't heard come up about the changing of variables, so just be careful. If they're talking about time, use T instead of X in place of it. All right, let me put points on that part. So you got a point for the slopes. You got 1 point for technically right here, okay? And then you got a point for the tangent lines. You got a point right there. And then you got a point for the final approximation, which we can kind of concluded over there. All right, part B. It says use d squared h over dt squared, so the second derivative, to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time t equals 3. So basically it's saying, hey, find the second derivative of this thing, but you got to be careful. And I fell into the trap when I tried to do the problem myself. Whenever you have dh dt and we're going to the second derivative, remember we are using implicit differentiation. They also tell us somewhere that it isn't here, so but it tells us that somewhere that h is a function, so that means we have to always take the derivative of h whenever we see it, okay, implicitly. So I'm gonna go ahead and take that second derivative. So d squared h over dt squared equals, so I'm gonna just keep the negative 1/4. The derivative of h is dh dt, and then the derivative of the 27. Technically, I really should distribute that. But when I multiply negative 1/4 times 27, I'm still going to get a number. The derivative of any number is 0. Now, I can't leave it like this, so I need to plug this dh dt back in. So d squared h over dt squared equals negative 1/4 times negative 1/4 times h minus 27. All right, I'm going to simplify a little bit. So, because I know negative times a negative is going to be positive 1/16 h minus 27. So the question was asking us, where is this, or is it an underestimate or an overestimate? Well, second derivative gets us concavity. So if I know if it's strictly concave up or concave down, that doesn't look like a C, that I can tell whether and I look at the tangent line compared to it, I can tell if it's an over or an underestimate. So I really just need to understand if this function is positive or negative. So I kind of need to know a little bit about h. There was a weird thing in the stem of the problem up here. It said that it never goes below 27 degrees. So that was a pretty cool trick, wasn't it? It changed my thing into a circle or an ellipse. So that means that if whatever number I put in here has to be bigger than 27 always, which means that this is always going to be positive. And this in front is always going to be positive. So I know it's always positive, which means that it has to be concave up like a cup. Well, if I drew something concave up and I draw a line tangent to it, you'll notice that the line is below the function. So that means that this has to be an overestimate. Okay. So I need to write that out a little bit. So I'm kind of analyzing. I don't know what I wrote down before. So I need to write something about that this is greater than 0 for t. I probably should not have all that mess in there. I'm going to leave it because it's notes, but I wouldn't leave that mess in there for t greater than 0. And then I can conclude, therefore, h is concave up for t greater than 0, and part A is an underestimate. Give you a minute. Okay, points on that part. All you got was a point for saying underestimate with the reason. So you had to have the reason there as well. Not a lot of points, but a point is a point. Get them where you can. All right. So they're going to switch things up on us a little bit in part C. They say that for t greater or less than 10, an alternate model for the internal temperature of the potato at time t minutes is the function g that satisfies the differential equation. So they gave us a new function, they gave us a new differential. Okay. They're still saying that it's not h anymore, but g of 0 is also 91. We are supposed to find an expression for g of t based on this model. What is the internal temperature of the potato at time t equals 3? All right, so if I've got to go from a kind of rate situation back to an integral situation, okay, I'm gonna put this to the chat and see if you guys think you know what you need to do, okay? What do we need to do to integrate that? There's a very important first step that you would be graded on. It's really hidden in this problem. So if you think you know what it is, think you know what the process is that we have to do first, what it's called, put it in the chat. I'll give you like a minute to do that. Oh, Connor's got it. Connor has more experience than the AB. I like to move it down. Move it down is kind of on the right track. Okay, so, and whenever I see that exponent, I do kind of think move it down, but here's the key. Do you notice how you have g here and g on the opposite side? In order to integrate, those have to be on the same side of the equation. So we are kind of moving it down, okay? We're going to use the process of separation of variables, and we've seen this before, and this is usually worth a lot of points. This part of the problem was worth 5 points. So we really hope we see a separation of variables because we know that they really emphasize that and they give us lots of points for separation of variables. The first step is to take this entire thing here, and we're going to divide it. Oh, that was a really nice rectangle. We're going to divide it over to the other side. So on the other side, it's going to look like 1 over g minus 27 to the 2/3 power. And then a dg equals. Notice I left the negative on the right. I have to take, there's no t's on the left side, so I have to take the dt and move it to the right side. So I'm going to multiply by it, so I get negative dt. So we have separated the variables. That is the first point. Everybody gets a point for that. You want to leave the negative on the right because you don't want to mess with it over here on the left, okay? We could have carried it, but then we're going to have a mess, okay? All right, we're going to put our integral symbols in there. Technically, I need a u substitution, but let's look at what u would turn out to be, okay? Because sometimes I ignore my u substitution. So if I did a u sub, it would just be g minus 27 and du, or u prime, it'd be du for us, du equals dg. I don't really get any weird funky coefficients I got to add in there, so there's really no point in me doing the u sub. If you've got a coefficient in front of the g, or you have an exponent specifically on the g, you need the u sub. Okay. Otherwise, if it's just a coefficient of 1 with a 1 exponent, you can kind of ignore u sub. All right, so I'm going to integrate it the way it looks. It is not a natural log. Now here's where the moving it part comes. I still have to move this up because my exponent is not a 1. So I'm going to move that up before I do any integration step. All right, now I'm going to integrate it. I'm going to go plus 1, so 3 over 3. Which means that I've got g minus 2 to the 1/3 power divided by 1/3 or multiplied by the reciprocal 3 over 1 equals negative, when I integrate dt, I get t plus c. Or if you want to write c sub 1, that's okay too. All right, there's a couple of trains of thought from here, okay? Either you solve it for g, that's what we're supposed to be solving for, or you plug in, and sometimes the algebra is icky. Or you go ahead and you plug in your initial condition. If we plug in our initial condition now, we get those points right away, and those are big points to actually do that process. Then we don't lose the initial condition point if we mess up the algebra somewhere else. Okay, so I'm going to go ahead and plug it in. The only time I really don't do that right here is if I'm going to have to exponentiate something. Then I'll kind of wait till I've done the exponentiation. All right, and really you could do it either way all the time. All right, I have that initial condition point. Still, they've done that point like 3 times in this problem. But now it's the g point instead of the h point. So I've got 3 times 91 minus 2 to the 1/3 power. Okay. There's something wrong. 91 minus 27. That's a little bit better. Equals, and then the t value is 0 plus c. All right, 91 minus 27 I found was 64 to the 1/3 equals c. 64 to the 1/3, although I could use that as my c and it would be okay, just be messy, is 4, and so c is equal to 12. I'm going to go ahead and go back to this line right here and plug that in, and then I have to get it solved for g. I'm going to do that work here. So I've got 3 times g minus 27 to the 1/3 power equals negative t plus 12. All right, and then I'm going to take and divide that 3 to the other side. So I've got g minus 27 to the 1/3 equals negative t plus 12 over 3. I'm not putting the 3 directly into the 12 because there's a plus sign in there. I got to divide the whole thing. To undo the 1/3, we would raise both sides to the 3rd power. And then I'm going to add the 27 to the other side. Ooh, that was kind of weird. It turned it into a circle. So g equals 27 plus, and it doesn't matter where I put the 27. If you want to put it at the back, you can. I just chose to put it in the front. Okay, so I'm going to do the points on this part. The points come from, number 1, separating my variables. So that's point number 1. Everybody can do at that point. You got a point for the antiderivative. So we got a point in this line here. You got a point for a combination of getting the plus c, the constant of integration, and for plugging in the initial condition. So that was all 1 point wrapped into 1. Oh, there's another piece to it apparently that I missed. Okay, And then we get a point for solving for this. But there was a fifth point, and I didn't read the whole problem. Okay? Look at this right here. It says the temperature at 3. Well, we found the temperature generically, but we didn't go back in and plug in the temperature at 3. Okay? So I need to figure that out. Okay? So I'm going to plug in again. So I've got G of 3 equals 27 plus -3 plus 2 over 3 squared. And that's it. You don't have to go any further than that, and that gets you your final point. Any questions on that one before I move on to the other problem? Oh, I'll get the joke master in here. Andy! Joke time! He's got a good one today. Why is it? It's plus 12. Thank you. You guys are watching the detail. That's really good. Any other comments before I have the joke master tell his joke? It is cubed. Thank you. I'm apparently having a bad afternoon here. Yes, Melissa, this is a particular solution problem. It was really disguised. They didn't say those words particular solution, but that's exactly what this was. Okay. And this wasn't that long ago. 2017 was 3 exams ago. So it's not, they might not say particular solution. All right. So you have to recognize that separation of variables. Your key, again, is making sure that your variables are on the same side as the d whatever the variable is. So the dg or the dt, they have to be on the same sides of the equation. Any other questions, concerns? All right, Joke Master Andy, take it away.
What is Donkey's favorite movie?
So what is Donkey from Shrek's favorite movie?
Star Trek.
Star Shrek. You're getting some.
Where's Donovan?
Donovan, I don't think, is here today.
Oh, he's
His
not.
sister is. Zeta's here. But Donovan's not. All right.
Oh, Sarah said she was close.
Well, she said Shrek.
Ah.
All right. Let's keep going. Okay, thank you. Thank you, Joke Master Andy. We will see you soon, okay?
Makahuti.
Yeah, is Ellie busy? Probably, huh? Okay. All right. Let's keep going. My husband just started a meeting, so this should be interesting. We'll see how much screaming happens in the next 30 minutes. Okay. 2017, number 6. So this is a super awesome problem because we have a table, so it's tabular. We have the graph, we have the graphical stem, and we've got an algebraic stem hanging out in there. So it's got a little bit of everything wrapped into one problem. I wouldn't be surprised if they did something like this to you. And if you look at the problems, not that bad. Slope of a tangent line. They give us kind of a random function that looks like a function inside a function. That's looking a little bit chain rule, I think, when I see that. This one here, looking like some chain rule and some trig that they're given, trying to sneak in there. Oh, sorry, here. Product rule, chain rule kind of stuff hanging out in there. And then with some trig embedded. And then here, is there a number? We already know. We know that's got to be a theorem problem somehow. Okay. So let's take a look at part A. Okay, so if I got something like this, I'd kind of be jumping for joy and be thankful. And just, you remember, you got to just break it down little part by little part, only go one problem at a time. Okay, and don't freak out. And if you don't understand how to do part A, go to part B. You might be able to get that. Okay, so let f be the function defined by f of x equals cosine 2x plus e to the sine x. So again, we've got trig embedded in everything else, and they have the exponential in there all roped into one. Let g be a differentiable function. The table, so we know g is differentiable. I don't think I wrote that anywhere. So g is differentiable. That's important because that also means that it is continuous. We might need that information somewhere. The table above gives the values of g and its derivative g prime at selected values of x. So if you want function g, you go to the table. If you want function f, you go to the algebra. Let h be the function whose graph consists of 5 line segments as shown in the figure above. And if you want h, you go to the graph. All right. We're supposed to find the slope of the tangent line to the graph of f, so make sure you know which one. Oh boy, they changed my f into, that looks really weird. Isn't that nice? Okay, so this is supposed to be the slope of tangent line to f at x equals pi. So make sure you know what you're working with. F is this one right here. If I need slope of a tangent line, that means I need to take a derivative. Okay, so f prime, it's doing crazy things. I got to take it off that thing. There we go. I won't get pretty shapes anymore, but I don't think we need them. All right, so f prime of x equals, all right, we've got some good use subbing going on, or no, use sub, some chain ruling going on here. So there's a chain rule there and a chain rule there. Maybe I'll do them in different colors for you. Okay, so this first one, and I know for BC I'm doing the chain rule a little crazy. It's okay, you'll live. We've got 2x equals u prime equals 2. Okay, then my outer function for that one, I'll go with black, would be I'm just going to say y equals cosine of u, and then y prime equals negative sine of u, which means when I write my function down, I've got the outside function, which is the negative sine, substitute that one in, the sine x, the 2 in, and then times the inside function, plus, all right, I'll use this pinky color. I've got my other u is going to be sine x, and its derivative is cosine x. And then the outside function is e to the x, which means its derivative is e to the u is e to the u. So I'd have the outside function, which is e, instead of u, I'm going to write sine x, times the inside function, which is cosine x. And I'm sorry, my work kind of ran into itself there. I do need to evaluate that at pi, because that's what it said, was to evaluate it at pi. So f prime of pi equals negative 2 sine of 2 pi plus e to the sine of pi times cosine of pi. All right, I do need unit circle. Okay, so we've got out 1 up 0, out 1 negative 1 up 0, and out 0 up 1. I don't think I need that part yet. All right, so sine of 2 pi is 0. So this whole part is negative 2 times 0. Plus e, sine of pi is also 0, so it's e to the 0. Cosine of pi is negative 1. So I have 0, e to the 0 is just 1, so I end up with negative 1 on that. And really you don't need to do anything. You can stop at the line once the e is gone and the trig is gone. All right, for that part, you would have you get 2 points for finding this. I don't know why they didn't break the 2 points up in any way by finding the derivative, but it just says 2 points for f prime of pi. All right, part B says that we have, let k be the function defined by k of x equals h of f of x, find k prime of pi. Well, there is 100% most definitely an inside function, which that means I have a chain rule. So I know my u is going to be f of x, which means that u prime is going to be f prime of x. So that's the derivative of my inside. My outside, which I'm going to call equals y for nothing better, is h of u, which means that y prime equals h prime of u. Okay, so I know that my derivative, find something else to put it in, k prime of x equals the outside function, u, instead of or h prime of u, instead of writing u, we're going to put the f of x back in, times the inside function, which is f prime of x. Now I need to plug in pi. So k prime of pi equals h prime of f of pi times f prime of pi. Okay, so I need to figure out what that is. So f is up here. So I'm plugging into that guy there. I need to plug into f of pi and f prime of pi. I think I already know what f prime of pi is, don't I? Isn't it -1 from part A? So I know that this part's -1. I need to plug into the actual f here of pi, so I'm going to do that work over here. So f of pi equals cosine of 2 pi plus e to the sine of pi. All right, well, I had my unit circle somewhere. I'm just going to write it again. All right, so cosine of 2 pi is 1. E to the sine of pi, well, that means it's e sine of pi is 0. It's a plus sign in there. And then anything to the 0 power is 1, so f of pi is 2. Excuse me. So I have h prime of 2 gets substituted in there. Hopefully you're seeing those lessons like from Algebra 2 Trig where I made you do all this stuff where you plug in stuff in from all kinds of crazy places. This is why we needed all that. All right, well, I still can't just leave it because I've got h prime of 2. I have to figure that out. Well, h prime of 2 is going to come from this graph here. 2 is right here. It's not read the value off. It's find, because prime means I have to find the slope of this graph right here. Well, I could probably read the slope off the graph. I know that the slope is down 1 over 3, so it's -1/3, and I can stop there at this point. If you really wanted the answer, it's +1/3. Okay, so the points on this part is you got 1 point for showing that derivative correctly, and you got 1 point right here for your answer. Okay, the next part, part C. So part C says and this is kind of crazy. They keep introducing all these letters, right? So you can't be scared of it. Take it one little piece at a time. Don't worry about the extra letters being in there. So let m be the function defined by m of x equals g of -2x times h of x. Find m prime of 2. Well, I've got a function times a function, which means I need a product rule. Okay. But I also have a chain rule embedded in there. So remember all those complex derivatives we did this year? This is exactly what they were. So this shouldn't be a huge, huge deal for you guys. But I also know I've got a little chain hanging out in there, okay? So I might do my chain rule work off to the side. In fact, let's do that off to the side real quick, just so we've got that taken care of. So I'm going to find g prime, or g, I know g of -2x is there. I'm going to get g prime of that. I'm going to take the derivative of it. So g prime, let me do my u. So my u equals -2x, which means that u prime equals -2. And then y, the outside function, is g of u. So y prime would be g prime of u. So the derivative is my outside function, which is g prime. Instead of u, we would write -2x times the inside function, which is -2. I'm going to choose to put that in front. So whenever I see the derivative, that chunk, I'm going to just write that. All right, so we're going to do derivative of m prime of x. Okay, so we do the derivative of our red, which we just calculated was -2 times g prime of -2x. Then I'm going to keep the green the way it is, h of x. It's product rule, so we're going to add. And then for our calculations, okay. I'll get that question in just a second, okay? Keep the red the way it is, so g of -2x And then the derivative of h is h prime, so derivative of my green. Okay. Let me get to the end and Lorenzo will answer your question. Then we're going to go ahead and plug in because we got to plug in a 2. So m prime of 2. So negative 2 g prime, negative 2 times 2, h of 2, plus g of negative 2 times 2, h prime of 2. All right, so I'm going to have to go back and use my my functions and my tables and my charts. So I've got negative 2. This is really a negative 4 there. So I'm really looking for g prime of negative 4. So I'm going to go back to my table. I'm going to go to negative 4, and I'm going to go to g prime, and it looks like I get to put in a negative 1. And then I've got to find h of 2. Now this is asking for the x value, and I just read the y value off the graph. There's a little bit of a catch, though, because it's not quite on. Okay. We looked at earlier that this slope was 1/3. So I know that if I'm at 1 here, that these have to be split into thirds right there. So this would be the 1/3, and that would have to be 2/3. So I know that that's times 2/3, but not 2/3 negative 2/3 because it's underneath the axis. Okay. All right, and then plus, and then again, this is going to be negative 4. So g now of negative 4 is 5. And then h prime of 2, we've already calculated that h prime is the 1/3, or actually negative 1/3. And you would want to stop right there. Okay, for those of us that really need it, the final answer on that one is negative 3. Let me do the points, and then I'm going to answer Lorenzo's question. So the points on this one is we would get 2 points for this derivative here, probably because of the chain rule piece being hidden in there and it being a chain with a product. And then you get 1 point for that estimate there. All right, I'm going to read Lorenzo's question while you're catching up here. Okay. So Lorenzo asks, how much work do we need to show for our calculations? If the problem is simple enough to do it in our heads, do we have to show the work? So I keep showing this process over here. Okay, let me point it out. So I keep showing this process. That's not the way the BC students are doing the chain rule. Okay, we can do the chain rule much simpler. I did the chain rule that way and set it up that way, so you guys, it led into U substitution this year for you. Okay, it is possible that really all you need to do for the chain rule. Let me go back to where my chain rule, or just look at this one here. If I'm taking the derivatives and it's my chain rule, I'm just going to take the derivative of the inside, write it out front, and then multiply it by the derivative of the derivative of the outside with the inside left alone. That's how I've taught it in years past. Okay, that's okay to go ahead and write it that way. You don't have to do this. No answer key is going to require this. No answer key is ever going to show your U substitution. No answer key is going to ever show any work for your chain rule. All they're looking at and concerned about is making sure you get that line right there written down correctly, okay? And that you have this plugged in correctly. That's all they're going to look out for the points. The amount of work is kind of up to what you need to do, okay, to get it done. All right. All right. They will, however, be looking for answers that match. I know we've got a couple of households that have more than one of you living in it. I know one's doing AB and one's doing BC. I'd make sure you're in separate rooms, okay? And that your one work doesn't look like the other. There might be some overlapping questions. We don't know, okay? So you want to make sure that you're really avoiding the security checks that they have built in, okay? All right. Any questions on C other than that? All right, here we go. Part D. All right, so is there a number C? What's the answer? Is there a number C? What's the answer? Always. Put it in the chat. I know some of you know it. You should all know it. Is there a number C? Yep, the answer is always yes. Okay. If they don't ask, is there, then maybe it's false, okay? But it said, is there a number C? We haven't run across one where it doesn't work, okay? There was the one the other day we read the goofy slope thing. I don't know if that was an AB or BC. It might have been in a BC lesson. I can't remember. But so you had to kind of just move the slope around a little bit, but there's almost always a way to find it. Okay. So I had to go back and kind of look at some things today. I went back in and I looked at my the notes for the theorems today. Okay, and I kind of found a chart. I'll try to put together some things so that you might want to be writing down, but you guys need to go through your notes and look for all your sentence frames that we had in there, especially for the theorems, for the maxes and the min problems. So you got that written out on a piece of paper somewhere and kind of made a little notes for yourself on a kind of like a little cheat sheet. Okay, you get to have the notes out this year. You might as well use that advantage. Okay. I would look at the one for the theorems and write down, there's a chart that had the EVT, the IVT, and the MVT in it. You don't need to worry about roles, but the other ones, it kind of had some information in there you probably want. Okay. Before I really do anything in this, the answer is yes, but I do need to say something about it being continuous and differentiable. I can't remember if we put it in a sentence or not. If I simply just made the statement that said, and I know that it's from way up here at the beginning. Oh, I don't think I wrote it down. Oh yeah, it said it. I wrote it, but I didn't write it down from the thing. So G is differentiable, so it is continuous. That was in the original stem of the problem. So I'm just going to write that here. So G is differentiable, okay, which implies that G is continuous. You can use a little arrow symbol, that's okay. It means implies. All right, no matter which one of the theorems I use, I need to have that information. And MVT. All right, so EVT, yes, it has to match, but it also has to say something about maxes and mins. So I'm not looking for a max or a min for extreme value theorems, so because it's extreme, so I know that that one's out. Okay. Then we are given the G prime, right? So that means I need to have the same thing. So I need to have a G prime. Here I need to go one level up. I need to have a G. So what's tricky about this is we actually have both. So I can't eliminate based on that we have that we're up one level or we're at the same level. The other thing that we need to look at is where we're looking at here. Okay. I need that Y value for intermediate value theorem, and it has to be able to be sandwiched in between the Y values that I am given. Okay, so if I go back here and I look between 5 and -3, oh, I guess it does fit in there. Oh, no, it doesn't. If you look at the Y values here, you'll notice that -4 does not fit in between those Y values. So that means I know it can't be the IVT. I'd have to use the MVT. And I know that was a little bit tricky. Okay. So we are going to use the MVT. All right. So we already know the answer is yes. By the mean value theorem. Okay. And I'm going to literally start restating this. There is a number, use the word number, not the pound sign, C, in the closed, or hashtag for you guys, the closed interval -5, I should have probably written the word interval, I said it and didn't write it, to 3, okay, such that, okay, now we actually need to do the calculation. This is where we actually have to perform the slope calculation, okay. You're going to use these values from the graph. So I'm looking specifically at, and I have to go back to the original value. You want to go one level up, okay, when you're looking at this. So I'm going to write the skeleton of it, and then I'll write the calculation. So I'm going to do G of, it was a -3. I kind of wrote over the top. G of -3 minus G of -5 over -3 minus -5. And I'm just going to do the calculation right within the sentence, and that's okay. So G of -3, it says in the chart, is 2. And G of -5, it says in the chart, is 10. Over -3 minus 5 is, or plus 5 is 2. So I end up with 8 over 2. And it's -8 over 2, which magically is equal to the number that we needed. Period. Done. All right. Oh, we need points. Did I do points on the last one? I did. Okay, so I didn't miss any of the points. I didn't have to keep asking you for them. You got a point for showing this part. And then you got a point for the overall justification. You had to include the differentiable continuous, but really they're looking for this mean value theorem, so you got 1 point for the justification. Okay? Andy, Kahoot time! All right, any questions? And that's, yes, that's it, Gabby. Okay? All right, any other questions on that? Don't leave yet. I know some of you leave for the Kahoot. I need to retake roll a little bit because I know that a few people came in. Yes, Anna. Yeah. Okay, so on hold on a second, I'm putting the password in over here. All right, so on the EVT is max min, so we toss that one out. Okay.
Yeah.
This time we couldn't tell between IVT and MVT just by looking at, because IVT it usually has to be the same and the same, right? This thing here has to be the same. Well, we had that in the chart. And for MVT, it has to be one level up. Well, we had that in the chart. So really what I came down to is I had to look at this Y value on my derivatives. And between here, I know that -4 would actually be up here as a Y value. Does that make sense? Okay. All right, I'm gonna look through the roll really quick again, okay? So if you want to leave for the Kahoot, don't do it for another like 2 minutes, okay? Because I know some of you aren't hanging around for the Kahoots. That's okay. You don't want the points, okay? But I want to make sure that roll is matching because I don't think it's matching right now. I'm missing a whole bunch of you because Ellie left on me and she's watching little boys right now, so it's better to leave them out there. All right, Andy, ready to fire it up?
Yes.
Okay.
Fire.
Let's fire it up. I think it's that one right there. Okay.
Yes, it is.
All right, hit classic. Here he goes. We'll type the number in.
I'll type it in.
Type it in. Okay, we're gonna type it in chat. Don't leave yet. I'll tell you when you can leave. Okay. All right.
1468006.
Okay, it's in the chat. I'm gonna go through the roll real quick. Okay.
All right, Miracle Tacos, Nate. Matt. Oh, Andrew, Happy, Matt, Nate. N-A-T, then N-8. Check it out. Carolina. No, I'm not going to do that. Here is here we go.
Okay, you got them all in there? How many you got? 22? Okay, we're gonna give you like 30 seconds to get in there. We're gonna get started.
Because we need 14 more people.
Let's see.
Just need in hell no.
Okay. All right, Andy, fire it up.
All right. Shrek trivia. I'll be in a Shrek. What company produced Shrek? Walmart Productions, DreamWorks, Disney Pixar. 5, 4. DreamWorks. I can't believe you guys guessed so fast.
I know it. I knew it wasn't Disney. That's kind of weird.
Maddie,
something
Big
not
Boy,
Disney.
Bodie, Bebe, Nate, and Melissa. What is the name of Shrek's princess?
All right, I got everybody for roll.
Fiona, Zoe, Bea, Donkey. Donkey. Fiona. Whoa! Somebody So a lot
Maddie
of
is
people,
up there.
Some people actually replaced. That was a lot of people that got replaced.
Yeah?
A lot.
A lot? Okay, keep going.
Right, here we go. How many Shrek movies are there? 1, 3, 4. Just say that's gonna be. Is one who does not know how many Shrek movies there are. There are 4. I did not know that. Most people guess 3. Whoa, Habib! Replace Maddie, Nate, Sarah, Carlos. Who knows? Hi. You can see me and Alex. Complete the link. Ogres are like blank. Onions, 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 onion, bamba. Onion. Yeah.
Have they been good?
Yes.
Okay.
We have all been good, Mom.
Okay.
Taha.
Has Andy been good, everybody?
Yeah, this one was a dumb one.
All right. That one was a dumb one. I think that's in there, though. It's because you have to peel the layers, okay?
Yeah. Whoa, Habib! Ouch! Here's an easy one. Where does Shrek live? I know you read that one. In a far, far away New York City, a swamp. I know! It is so easy. A swamp. Ogres live in swamps. Sarah and Carlos got replaced by each other, but Sarah's on fire already.
Oh.
And that can't be.
What
Come
happened
on.
to Maddie? She was up there when I left.
What is the name of Lord Farquaad's city? Blocked the North Pole far, far away at Syria? What is that? You see two?
Cameron made it into the top 5 at all? Hopefully he goes nuts for Midnight. I think that's why he comes.
Whoa!
Oh, he had a lot of change.
Yeah.
All right.
True or false? Does Shrek loves Fiona? Oh, true or false? You guys know this! It's true! Whoa. Okay, just a little change in the top 5. Donkey from Shrek is voiced by Terry Crews, Brad Pitt, Eddie Murphy, Kevin Hart. Okay. Look at this. Check yourself before you check yourself.
I borrowed this from somewhere else, so keep
going.
Okay.
Benji and Habib, not Night. What are Shrek and Donkey starring at? The Swamp, Information Booth, Gate Castle. Staring. Information.
All right, hit the next.
Look.
No. I didn't even know that button was there. Keep going.
Yes. I will use it. Whoa, Habib's going down step by step.
Natalie's up at the top. Okay, keep going. 3 questions.
Who created the song Rockstar from Shrek? Smash Mouth or Dreamer?
Oh, they all got
yes. It. No. 3.
Oh, 3. I'm sorry. I apologize. Are we going to listen to that? Only like 5 seconds. Mommy has started. All right. Keep going.
Whoa, Habib and
Habib is
Lorenzo.
falling down on the job.
How does Donkey's attitude about life positively affects Shrek. Donkey drives Shrek crazy. He gets Shrek to realize that he needs other. He gets Shrek to whistle. Donkey gets Shrek to interrupt Fiona and Farquaad's wedding.
A while.
Oh wait! I was so close.
Okay.
He gets Shrek to realize that he's I was thinking of Donkey gets Shrek to interrupt
Alright.
Fiona and Farquaad's wedding. Yeah, that's me. That picture is me. Literally.
Okay.
Oh.
Last one. Bonus question.
Ellie Bauer was in Shrek's musical. Which role did not play? Young Fiona, grown up Fiona, Gingy, Tat, Dancing Rat. I know this one! Grown up Fiona! She was young Fiona Gingy. Did you know that she wasn't grown up? There was a young one too.
You said did not play. Alright.
Lorenzo, nice. You just got for fifth. Natalie. Oh, somebody just took her place.
Who's in number one? Who made it?
Sierra
One today.
and Big Booty.
Oh.
It's not up there.
Alright, close it out.
Sorry, Hippie. I love you.
Okay. Alright, guys. I'm going to take down this. Alright, we're going to hit this button and hit. Alright, AB, we're going to say goodbye to